All right, ladies and gentlemen, we're going to do some net ionic equations, and I am very aware that sometimes these are hard to see. Unfortunately, this is what my iPhone can do, so this is what I am going to do. I'm just going to run through this homework and kind of go with what I know. So the first thing it asks for is the complete balanced equation, and it actually gives this to you. So potassium is just K, solid, plus water. Water is a liquid, H2O, liquid. Makes potassium hydroxide, KOH. Now, I don't know what state of matter that is, so I can look right here and look for OH. And that says OH is insoluble, so it should be a solid except for with alkali metals. And that's what potassium is, so this is aqueous, plus hydrogen. Now, I know hydrogen is H2, okay? And I know that it is a gas because it's by itself and it's red on the periodic table. All right, this is not balanced, so, or is it? Nope, it's not. The hydrogens aren't balanced. So I need to somehow figure that out. So I'm going to put a 2 here, and when I put that 2 here, I'm going to need a 2 here and a 2 here. So we are super balanced and everything is cool. Part B says, write the total ionic equation. That means I'm just writing everything that can be broken down into ions as ions. So can a solid be broken into ions? Nope. So it's still 2K solid plus, oh man, can I break down the liquid water? Nope, it's not aqueous, so it's H2O. Okay, still liquid. Makes, all right, now this is aqueous, so this gets broken down into its ions. So this would be 2K plus ions, and those are aqueous, plus 2OH minus ions, those are aqueous. And then we look at the last part, this is a gas, it can't be broken to its ions, so it's H2 gas. Now, ladies and gentlemen, when we look at this is a huge thing. We're looking for spectators, so we have the net ionic. So if there's anything on each side, they cancel out. Well, there isn't anything the same on each side, so B, in this case, the answer to B is the same as C. Okay, so we have done number 1. Number 2, zinc plus hydrochloric acid makes zinc chloride plus hydrogen. So I'm going to write that out. You had this in your lab, and zinc is a solid. All acids are aqueuses. Makes zinc chloride, ZnCl2. Oh man, how do I know whether it's aqueous or not? I go to chlorine. That says it's soluble, so soluble means AQ. And is it with zinc? Or yep, there's not any exceptions, so that's totally aqueous. Plus hydrogen, and that's H2 gas, remember Hunkelbrief. So now we're going to do the same thing for the overall ionic, is we're going to break it down where only our aqueuses break down into ions. Oh wait, I forgot to balance. So now I'm balanced, okay? So I'm going to do this. Zn solid is still Zn solid, but this is aqueous, so I'm going to say 2H plus aqueous plus 2Cl minus aqueous. I do break it up, and that coefficient goes to each part. Makes 1 Zn plus 2 aqueous plus 2 Cl minus aqueous plus H2 gas. All right, and I know I got a little big there, so I'm a little longer than I need to be. So now the next part is to make the net ionic equation, we have to cancel out any spectators, anything that's the same on each side. Do you see that 2Cl minus and this 2Cl minus? We don't need those bad boys. So the overall equation is zinc solid plus 2H plus aqueous makes Zn plus 2 aqueous plus H2 gas. And ladies and gentlemen, that is the start of what we call a redox equation, and we'll deal with redox next week. But this is just a nice net ionic equation. I am going to skip until we go down to iron sulfate and barium nitrate, number 5, because I want to show you a big equation. So here we go. And I want you to predict the products. This is a double replacement. Iron is going to end up with nitrate, barium is going to end up with sulfate. So if I were to write that, it'd be iron 3 nitrate plus barium sulfate. So I'm going to rewrite that as an overall equation. So that would be Fe2SO4 3. It's going to be aqueous. Okay. And then we're going to have Ba NO3, 2 aqueous. That's a nitrate. All nitrates are aqueous. Makes Fe, NO3, 3 aqueous. Plus barium sulfate, BaSO4. Oh man, BaSO4, what state is that? Well, I have to take out this beautiful solubility rules. I go to SO4. It's aqueous except with SrBa. Oh, that means it's a solid. So solid. Okay. So there is my overall equation, but it is not balanced. So I'm going to balance this bad boy really quick. I have a 2 and a 3 with nitrate, so I'm going to make them 6. And then I'm going to put a 3 here and a 2 here. And that beautifully works out nicely. So you have all of that balanced. And now it's time to write out all of your ions. Holy moly. I might even move my camera. I'm going to move it up higher so you can see the whole thing because, see, dear Lord, this is a lot of ions. So here I go. 4 Fe plus 3 aqueous plus 6 SO4 minus 2 aqueous plus 3 Ba plus 2 aqueous plus 3 NO, oh, it's not 3, it's 6. See, 3 times 2, 6 NO3 minus aqueous. I've taken all of those that have broken up. And now I have, how many is this? 2 Fe. Oh man, was my thing not balanced? Did I mess that up? Oh, I didn't need the 2 there. So this should be just 2 and 3. I balanced wrong. Oh man. Now I'm balanced right. I think I'm good. Okay. So this is 2 Fe plus 3 aqueous plus 6 NO3 minus aqueous. But does the BaSO4 break up? No. It's a solid, so it stays together. So now we have the overall net ionic equation, the overall ionic. Now we need the net. So we need to get rid of anything that's just watching. It's a spectator. This iron and this iron are watching. NO3 and NO3 are watching. That leaves us with just 3 things. So this is 3 SO4 minus 2 aqueous plus 3 Ba plus 2 aqueous makes 3 BaSO4 solid. You can reduce that, but you do not have to, okay, for this case, okay? And that is your net ionic equation. Now, just to make your life trickier, I'm going to do one more, okay? And I'm going to show you a simpler way to do it. And you can do this way if you get it. If you don't get it, go back to the other way, all right? So I'm going to have this one, iron 3 nitrate and barium chloride. So we have sort of the same thing going on. Iron chloride. Well, iron chloride, iron. Iron is what, PB or Fe? Fe. So this one actually, if I look at this, nitrate and chlorides, ladies and gentlemen, this is going to become barium nitrate. That's soluble. Iron 3 chloride, that's soluble. This is a no reaction. So I'm actually skipping that one. Let's see. I want to do another double replacement. So I'm going to skip to the next page. And I am going to do number 1 on this next page, okay? And I'm going to show you how the skip works. All the other questions I will answer and put on haiku so you can see them, but I'm going to talk through this one. So this makes silver chloride and zinc nitrate. So if we were to write this out, it would look like this. AgNO3 aqueous plus ZnCl2 aqueous makes AgCl. What is that going to be? AgCl? Oh, Cl minus. And with Ag, that's solid. Okay, plus, all right, ZnNO3 2 aqueous. All the nitrates are aqueous. All right, I'm going to balance this because I don't like that there's 2 nitrates over here and only 1 here. So I'm going to put a 2 and a 2. So this is all balanced out. Now, for a net ionic equation, what matters and what doesn't come apart are the solids, liquids, and gases. The only thing we have here that doesn't come apart is solid right here, this AgCl. So what I'm going to do for my net, at the end, I know I need 2 AgCl solid. what makes up those two AgCl solids? Well, guess what? It's got to be 2Ag plus 1 aqueous. And that comes from right here. That's where it's coming from. Plus, what else? 2Cl minus aqueous. And those come from right here. The rest of them, the zinc and the zinc, cancel out. The NO3 and the NO3 cancel out. So it's a little bit faster if you look at what your final product is, okay? It shouldn't take that long if you get this. If not, write everything out and see what cancels, okay? I'm going to do all of the rest of this so you have an answer key, and then we will go from there. See you later.